So as we deal with some of our reactions of amines here, reminder that most of the most important reactions of amines are things that we've covered in previous chapters. And so here, our questions are just starting with some relatively straightforward reactions. Amines, in general, are weak bases. And that's because they have that lone pair on nitrogen. And so if you react an amine with a strong enough acid, such as we have HCl here, then it undergoes an acid-base reaction, and we get a protonated amine. Same thing in part B. Strong acid reacts with an amine, and we get an ammonium salt. And we can continue through the rest of these examples, but same thing is going to happen. And the fact is, it actually doesn't matter whether we start with a primary, secondary, or tertiary amine. For almost any amine that we add a strong acid to, we add a proton to it, it becomes a charged species, and we have a chloride counterion. Now, what does this matter for? What's it useful for? Well, one of the things it can really have an impact on is what you see here. So, question number 2 here says we have a mixture of aniline, benzoic acid, and benzene. And what we're looking for here is a way that we can separate them. Now, the first thing we might think about is what are they soluble in? Because that's the easiest way to separate them. And all 3 of these are going to be organic soluble. And because they've all got 6 carbons or more in the case of benzoic acid, none of these are likely to be water soluble. So if we take them and we add an organic solvent like CH2Cl2, methylene chloride, all 3 of them are going to dissolve. But at that point, then I'm going to add sodium hydroxide. Why do I add sodium hydroxide? Well, we know that a carboxylic acid, such as benzoic acid, will dissolve in sodium hydroxide. Why is that? Well, adding a base such as sodium hydroxide to a carboxylic acid will form a carboxylate salt. And we know that a carboxylate salt, regardless of how many carbons it has, is going to be water soluble. So our water layer will now have the deprotonated benzoic acid. Whereas the organic layer will still have the aniline and the benzene. So we've now separated one of our components out. We've gotten the benzoic acid out. And if we want to actually recover it as benzoic acid, we would take this, we would add HCl, and that would reprotonate it back to the carboxylic acid. But what about to separate the other 2? Well, we just learned that if we add HCl, that will protonate the aniline, the amine. Just like with carboxylic acids, when you make something into an ionic salt, it becomes water soluble. And then the benzene will be off by itself, still in the organic layer. And finally, if we want to get that back to aniline, we could add a base, which would remove that extra hydrogen and give us aniline. So basically what we've done in this question is we've manipulated these two molecules, the carboxylic acid and the amine, using their acid-base characteristics. And by doing that, we've managed to separate the three molecules out.